students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as hydroxy compounds. We're going to do phenols right now, right? Now what do you mean by phenols? Now phenols are hydroxy derivatives of aromatic hydrocarbons. Alcohols were hydroxy derivatives of aliphatic hydrocarbons. The difference between alcohols and phenols are, in the case of alcohols, they are derivatives of aliphatic hydrocarbons, and these are derivatives of aromatic hydrocarbons. Right? So how do I define phenols? Definition: they are hydroxy derivatives. They are hydroxy derivatives of aromatic hydrocarbons in which the hydroxy group is directly attached. A hydroxy group is directly attached. In which the hydroxy group is directly attached to the carbon atom of aromatic ring. Right? So that is what is phenol. They are hydroxy derivatives of aromatic hydrocarbons. Right? They are nothing but they are monohydroxy derivatives of benzene. They are also called as monohydroxy derivatives of benzene. Fine, do you get this thing here? Now, the aromatic hydroxy compound in which one or more hydroxy group is directly attached to the aromatic ring is called as phenol. Right? Now let's see the structure of phenol. Or if you want, you can write another definition. Aromatic hydroxy compounds in which one or more hydroxy group are directly attached to the aromatic rings. Are called phenols. Right? Now let us try to see the structure of phenol. Structure of phenols. Benzene ring with a hydroxy compound attached to it. Right? You can have a hydroxy compound where you can have a structure like this, alternate single and double bonds, or I could draw the structure of phenol like this. Benzene ring with OH. Right? Now, in benzene ring, I hope you all know the numbering. In benzene ring, this is called as the first position, second position, third, fourth, fifth and sixth. Right? The second and the sixth position are called as ortho. Right? The third and the fifth position are called as meta, and the fourth position is called as para. Fine, do you get this thing here? Now, phenols are also called as carboxylic acid because they donate hydroxy compounds as protons. Phenols are also known as carboxylic acids. Phenols are also known as carboxylic acids because it donates they donate because they donate hydroxyl hydrogen as proton. Hydroxyl hydrogen as proton. Fine. Now, the acidity of phenol is due to the resonance stabilization of phenoxide ion. The acidity of phenol is due to resonance stabilization of phenoxide ion. Stabilization of phenoxide ions. Fine, do we get this in here? So if I have phenol, phenol will get converted into a phenoxide ion by donating a hydrogen proton. This is phenol, this is phenoxide ion. Can we get this in here? Now, what do you mean by resonance structure? Resonance structure have negative charge on ortho and para position. So when you have negative charge on ortho and para position, then it is called as resonance structure. Now when it donates a proton, it acquires a negative charge on ortho and para position, and that is the reason why they are said to have resonance structure. Fine, do we get this in here? Next, let's see methods of preparation. Methods of preparation. First method is called as dose process. Now what is dose process? Chlorobenzene is heated with 6 or 8% aqueous solution of sodium hydroxide, right? At 623 Kelvin under 300 atmosphere, right? So in that case, by dose process, you have chlorobenzene is heated with sodium hydroxide. In dose process, chlorobenzene is heated with sodium hydroxide. So chlorobenzene, this is your benzene ring, this is chlorobenzene. Chlorobenzene reacts with sodium hydroxide, right, at 623 Kelvin under 300 atmosphere pressure, right? You would have substitution reaction where you will have sodium reacting with chlorine to form sodium chloride plus OH reacting with H to form water plus you will get O remains and Na remains. One O remains and Na remains. This is chlorobenzene. Chlorobenzene reacts with sodium hydroxide to give you sodium phenoxide. Sodium phenoxide. The sodium phenoxide so formed then reacts with hydrochloric acid. Sodium phenoxide ONA reacts with hydrochloric acid to give you phenol. Gives you phenol and sodium chloride, right? So this is going to be sodium phenoxide and this is phenol. Fine, do you get this in here? I could have done dose process even by using water and carbon dioxide, right? Wherein instead of reacting it with hydrochloric acid, had I reacted it with water and carbon dioxide, even then I would have got phenol. I can say or sodium phenoxide ONA, sodium phenoxide, reacted with water and carbon dioxide. Reacted with water and carbon dioxide at 300 atmosphere pressure. When you reacted with water and carbon dioxide, again you get phenol and you get sodium bicarbonate. Right? This method for preparation of phenol is called as dose process. Right? Next method for preparation is called as rastering process. Right? Rastering process. Now in rastering process, again you have chlorobenzene, but instead of reacting it with sodium hydroxide, it is reacted with superheated steam at 723 Kelvin in the presence of cupric chloride as catalyst. So you have chlorobenzene with superheated steam at 723 Kelvin. Right? So you have chlorobenzene reacts with water, that's steam, in the presence of cuprous chloride at 723 Kelvin. Right? So in that case, straight away you get phenol. You will have phenol OH plus hydrochloric acid. Substitution reaction. Chlorine gets substituted by hydroxyl compound. Right? This is chlorobenzene. This is steam phenol. Fine, do you get this thing here? You can also do this, instead of heating it till 723 Kelvin, I could also do this reaction at 698 Kelvin by using silicon oxide as the catalyst and Instead of using cuprous chloride, I could also do the reaction this way, where I could have chlorobenzene reacting with steam. Instead of using cuprous chloride, I could use silicon oxide. Advantage, I will have to use a temperature of 698 Kelvin. Right? Steam and same reaction, you will have phenol and hydrochloric acid. Right? Chlorobenzene, steam, phenol. Right? That is your second method for preparation, that is called as rastering process. The third method for preparation is from benzene sulfonic acid. Benzene sulfonic acid. Preparation from benzene sulfonic acid. Now benzene sulfonic acid is first neutralized by using sodium hydroxide, and after it has been neutralized, the salt of sodium benzene sulfonate is dried on vaporization to remove water to give you phenol. See, I'll show you. From benzene sulfonic acid, you have benzene sulfonic acid reacts with sodium hydroxide, NaOH. Right? Let's see this. You have phenol reacts with, you want to make phenol, sorry. You have benzene sulfonic acid, SO3H. Benzene sulfonic acid reacts with sodium hydroxide, right, to form water, H2O, That means hydrogen is going to be substituted by sodium. SO3Na. Right? This is your benzene sulfonic acid. Benzene sulfonic acid reacts with sodium hydroxide to form sodium benzene sulfonate. Right? The sodium benzene sulfonate so formed is further reacted with sodium hydroxide. This was here sodium hydroxide was in aqueous state. Right? This is further reacted. Sodium benzene sulfonate is further reacted with sodium hydroxide at 573 Kelvin, right? In which case you will get Na reacts. So in that case you will get sodium sulfate Na2SO3 plus water plus sodium phenoxide, right? So sodium benzene sulfonate reacts with sodium hydroxide to give you sodium phenoxide. Right? Now the sodium phenoxide so formed further reacts with hydrochloric acid, dehydration. Right? Sodium, this is my sodium phenoxide reacts with hydrochloric acid, dilute to form phenol and hydrochloric acid. This is sodium phenoxide. Is phenol. Fine, do you get this thing here? So this is how you prepare. Yeah.
It will form HCl or NaCl?
It will form NaCl, sodium chloride. NaCl. H has been substituted here. Na goes down here, so it will give you NaCl. So you get phenol and sodium chloride. Right. Next, the next method for preparation is from cumene. Cumene, the IUPAC name is isopropyl benzene. Right? Now let's see this. This is generally your commercial method of preparation of phenol. So for commercial method you generally use cumene. Here you have oxygen is bubbled into a suspension of cumene to prepare this. What happens when cumene reacts with oxygen, right? Benzene, right? Isopropyl, that means it will be in the branch. Propyl, that means there will be 3 carbon atoms. Now 1, 2, 3. So H, H3, H3. This is your isopropyl benzene, or which is called as cumene. Reacts with hydrogen gas. No, not hydrogen, sorry, oxygen gas. Reacts with oxygen gas in the presence of sodium carbonate at 373 Kelvin. Right? You would have acid that would be formed. You would have addition reaction taking place where you will have benzene ring CH3 CH3, both the O's react here OOH. Right? This is called as cumene hydroperoxide. Cumene hydroperoxide. This is cumene. So cumene, when it reacts with oxygen, gives you cumene hydrogen peroxide, then which is then decompose by using dilute sulfuric acid. So cumene, hydrogen peroxide, CH3 acid OOH is decomposed in the presence of dilute sulfuric acid. Heat. Since you are heating this will decompose to give you phenol. So that means benzene ring and OH is out. So that leaves you with CH3COCH3. CH3COCH3. This is acetone, phenol, and this is cumene hydroperoxide. Right? That's how you prepare phenol from cumene. Right? The next method for preparation of phenol is from aniline. This is also called as diazotization. Right? So the process by which aromatic primary amine is converted into diazonium compound is called as diazonization. See, here what you have is you have aniline, which is first converted. Aniline is treated with nitrous acid. Right? What is aniline? Aniline is nothing but aromatic primary amine. Aromatic. So you need your benzene, you need, right? Primary amine, NH amine, so NH2 is treated with nitrous acid. How? Will first reacted with sodium nitrate and hydrochloric acid. If I reacted with sodium nitrate and hydrochloric acid, then what you will get is benzene diazonium chloride. You will have an addition reaction taking place. You have one nitrogen is here, one more nitrogen comes in. CF, right? This is called as benzene diazonium chloride. Right? This is your diazotization process. So first you convert aniline into benzene diazonium chloride, which is then treated with warm water to give you nitrogen gas, hydrochloric acid and phenol. Fine, do you get this thing here? So those are the different processes by which you prepare phenols. Let's see the reactions of phenols. Reactions of phenols. Right? First, let us see bromination. The first reaction is bromination. Right? What happens when phenol reacts with bromine? Right? Phenol with bromine gas. Right? What happens when phenol reacts with bromine gas? So phenol reacts with bromine gas in the presence of methyl chloride methyl dichloride in the presence of chloroform. In the presence of chloroform at 273 Kelvin. Right? Here, in this case, you have two bromine, so you will require two phenols. One of the phenol will combine with one bromine, the other will combine with other bromine, and OH, the two H's will be separated out. See, here you will get one phenol. One phenol will combine with bromine to give you orthobromophenol. Another phenol will combine with bromine to give you parabromophenol, and you will get hydrogen bromide, 2HBr. Right? So in this case you have phenol reacts with bromine to give you O-bromophenol, P-bromophenol, and hydrogen bromide. Right? P-bromophenol is going to be the major compound there. Right? Now same, instead of reacting it with bromine, I can react this with bromine water. Phenol with bromine water. Right? What happens when phenol reacts with bromine water? When it reacts with bromine water, phenol reacts with bromine water. Right? In which case you will get hydrogen bromide, HBr. Right? Now since I need this, you will have 3 HBr plus 246 tribromophenol. Right? You will get a white precipitate of 246 tribromophenol. This is phenol. This is 246 tribromophenol. This is going to be a white precipitate. Right? Right? Okay, that was bromination. Next, let's see the next reaction, nitration. Right, let's see the next reaction, nitration. What happens when phenol reacts with dilute nitric acid? Phenol with dilute nitric acid, HNO3. Right? Phenol reacts with dilute nitric acid. So in that case, you have phenol reacts with HNO3. Phenol reacts with dilute nitric acid. We write this dilute here. Right? In this case, same thing, you will get O nitrophenol, P nitrophenol, and water. You need two molecules here and you need two this. So you will get phenol, you will get O nitrophenol plus P nitrophenol plus water. Right? So here you have phenol, this is O nitrophenol, P nitrophenol, and water. The major compound here will again be P nitrophenol. Fine. Next, what happens when phenol reacts with concentrated nitric acid? Phenol with concentrated HNO3. Phenol reacts with concentrated nitric acid. Phenol with HNO3. concentrated heat, right? In which case you will get heat, that means dehydration. Water molecule is out and you will get 246 nitrophenol, trinitrophenol, NO2, NO2, NO2. This is 246 trinitrophenol. Common name picric acid. Phenol. Right? That's your nitrate reaction. Next reaction, sulfonation. Right? Sulfonation reaction. What happens when phenol reacts with sulfonic acid? Phenol reacts with concentrated sulfuric acid. Phenol with concentrated sulfuric acid. Phenol reacts with concentrated sulfuric acid at low temperature. Phenol OH reacts with concentrated sulfuric acid at low temperature, that is 288 to 293 Kelvin. Right? Sulfuric acid, dehydration, water molecule is out. Phenol as it is, SO3H. Right? You will get O-phenol sulfonic acid. This is phenol. This is O-phenol sulfonic acid. This is concentrated. This is at low temperature. Now the same reaction can be done at high temperature also. Phenol with concentrated sulfuric acid at high temperature. Right? Phenol, concentrated sulfuric acid, H2SO4 at high temperature, 373 Kelvin. Right? Will give you phenol sulfonic acid and water, dehydration, plus you will get phenol P sulfonic acid. This is phenol and this is P phenol sulfonic acid. Right? That finishes all your reactions of phenol. Now let us distinguish between alcohols and phenols. Distinguish between alcohols and phenols. Right? Alcohols, phenols, test. How do I differentiate between them? Nature. Right? Alcohols are neutral. Phenols are acidic due to the resonance structure. Right? Next, reaction with action with bromine water. Action with bromine water. Right? They don't react with bromine water, no reaction. And here you will get a white precipitate. We saw this reaction where you get a white precipitate, you get 2,4,6 tribromophenol. Right? Next, action with sodium hydroxide. With sodium hydroxide, no reaction. And here you will get salt and water. Next, action with ferric chloride. you will not get any color change. No violet color. Here you get violet color. Right? This is because of the formation of ferric phenoxide. Next, action with benzene diazonium chloride. Action with benzene diazonium chloride. You have no color that is formed, so there is no dye formation, and here you will have a color that will be formed, and the dye will be called as the azo dye. Forms azo dye. Right? Next, with sodium metal. Right? Will give hydrogen gas. Here there will be effervescence and will give H2 gas. There are no reaction. Right? Litmus test. Litmus test. Litmus test, neutral to litmus, no color change. Since this is acidic, blue turns red. Right? Now that's how you distinguish between alcohols and phenols. Now, what are the uses of phenols? What are the uses of phenols? Now, first, it is used for making azo dye. It is also used for making phenolphthalein. Then it is used for making picric acid. Where do I use picric acid? Picric acid is used in explosive. All your bombs, they use picric acid. Right? Then it is used for making cyclohexanol. Cyclohexanol. What is a cyclohexanol? It is a solvent which is used for rubbers and liquor. Then it is used to make, it is used as a preservative in ink. So that there is shelf life for ink, buffer solution. Right? Then it is used as an antiseptic in soap, ointments and lotions. Antiseptic in soaps, ointments and lotions. Right? Then it is used for preparing aspirin. Aspirin is made up of phenol. Right? So those are the uses of phenol. That finishes the chapter. We'll stop this here for the day. Thank you very much.